Our next speaker is Foad Taghdiri. Now, he was introduced already to you this morning, and I actually don't have any notes on him for this afternoon, so I hope everybody can recall his impressive track record. Okay, and he's going to be talking about a novel visual task as an indicator of white matter integrity and cortical thickness in retired professional athletes with multiple concussions.
Hello again. Another project that I'm also involved in is looking at a novel visual task as an indicator of white matter integrity and cortical thickness in retired professional athletes with history of multiple concussions. Today we heard several times about chronic traumatic encephalopathy and CT, so I won't go over it again. So as you all know now, we need objective and quantifiable methods for accurate diagnosis and prognosis. Patients with post-concussion syndrome have different kinds of symptoms. Some of the most common symptoms are impairment in executive function, memory, and visuospatial. And so the aim of our study was to evaluate the contribution of white matter integrity and cortical thickness to performance on a novel visual scanning task of processing in speed in retired professional athletes with a history of multiple concussions. For visual scanning tasks, we used visual attention scanning technology, or VAST. VAST is developed by Elmar company in Toronto, and it consists of 3 infrared light sources, an IR video camera, and a processor. And our subjects just sit 65 centimeters from the monitor and do all the testings with just moving their eyes. Our VAST technology eye tracking system includes different types of eye tracking assessments, and one of these assessments is matching familiar figure test, or MMFT. This test includes 22 slides, and on each slide there is a master image on top and 6 variants below. And we ask our subjects to find the identical image to the master image. So they need to go back and forth between the variants and the master image and select the correct answer by just looking at the number below here. We think that different cognitive aspects are important effects on this test, for example, attention, or executive function, or especially working memory, because patients need to memorize and remember the shape of the master image before selecting the right answer. For this test, we measured a percentage of correct first selection, or PC, average response time, or latency, which was the latency to the first correct selection, and the ratio of the 2. So percentage of correct divided by latency. We used this ratio as a measure of efficiency. I'll get back to this soon. Again, for MRI acquisition, we used the 3 Tesla MRI scanners, and diffusion gradients were applied in 60 spatial directions. And as I explained this morning, for DTI, we used the 4 major DTI measures: axial diffusivity, or AD, radial diffusivity, RD, mean diffusivity, and finally fractional anisotropy. And these 4 measures are measures of integrity of the white matter. So for white matter tracts, it's believed that better integrity tracts should have higher FA values and lower diffusivity. We again used FSL software and did seed-based probabilistic tractography to reconstruct right and left uncinnates, SLF, cingulum, and corpus callosum. The yellow arrows here are pointing to the seeds we located where these tracks are known to pass through a bottleneck. And for cortical thickness and gray matter volumes, we used free surfer version 6, and we were interested particularly in right and left entorhinal cortical thickness and right and left hippocampi volumes. We picked only these two regions because, as I mentioned, we think that this visual scanning assessment that we have is trying to test working memory and memory. So, and these regions are part of important regions of brain for memory. So we picked it too. All of our patients underwent a comprehensive neuropsychological battery, including symbol-digit modality test or STMT, ray visual design learning test, RVDLT, and digit span backward or DSB. So in total, we had 41 patients, 34 football player, 4 hockey player, and 3 boxer. All of our subjects were men with mean age of 53.7 years old. Just to get a sense of what this eye tracking assessment is measuring, you can see here some of the correlations with some of the neuropsych tests. For example, there's a significantly positive correlation between RVDLT Z-score and percentage of correct answer on MFD. So we saw that percentage of correct answer was correlated with memory and executive function neuropsych test. And also there was a negative correlation and association with a score in anxiety in personality assessment inventory or PAI. Again, we saw that there's a significant correlation between the latency on MFD and reaction time on SART. So this slide shows that at the beginning, there's a positive association between latency on MFD and percentage of correct answer. But then it goes to become flat. So we think that there's an optimum point here that patients can be fast and correct. And they need to balance between latency and correct answer. So that's why we measured, why is it going backwards? Sorry. That's why we measured the ratio of percentage of correct divided by latency as a measure of efficiency. We saw that there is a significant correlation between this ratio and integrity of left uncinate tract, particularly FA, MD, and RD of this tract. Similarly, we saw positive correlations between this ratio and right and left entorhinal cortical thickness, particularly at the right side. So when we saw that these three variables are correlated with our eye tracking assessment ratio, I mean this ratio, percentage of correct divided by latency, we were interested to see which one of these variables contributes most to this ratio. So by using a regression model, as you can see here, right entorhinal thickness is the one which is contributing most to this ratio. So in summary, visual matching familiar figure test or MMFT may be useful for assessing executive function, particularly working memory, and impaired performance on MFT may reflect loss of integrity in left uncinate fasciculus and lower in entorhinal thickness in retired professional athletes with history of multiple concussions. Therefore, we think MFT may be a sensitive test for capturing some of the structural changes that occur in a retired professional players with history of multiple concussions. Again, we would like to thank all the subjects who helped us with this project, And these are my references, and thank you so much for listening.
If I could ask you to hold on to your questions for 1 minute, I'm going to go rogue here because I found Foad's bio. So I'm just going to say a couple of words, which is that, first of all, he's a member of the Canadian Concussion Centre, one of our colleagues. He's currently a postdoctoral fellow at the Tan Centre for Research in Neurodegenerative Diseases at U of T, working with Dr. Tartaglia. He previously completed his MSc with the Institute of Medical Sciences at U of T, and he received his medical degree at Tehran University of Medical Sciences.
Thank you.
Are there any questions? Charles?
Sure.
How does it relate to our previous finding of effect of the uncinate fasciculus in relationship to impulsivity? Like it's sort of the second piece of evidence that there's something wrong with that particular tract.
First, this MFD test sometimes is used, especially for ADHD children, as a test for impulsivity. So they think that people who are more impulsive tend to pick their answer faster. We didn't find any association with impulsivity. As uncinate tract, I remember Ruma's paper. It was right uncinate, as I remember, was associated with impulsivity, but our correlation with, was only with left side. We didn't find anything with the right side. Okay, thank you so much.
Thanks, Foad.